So I posted Dr. Stevens' answer to the textbook version of this question. And I do this because that way we're all looking at the same mean, same standard deviation, same sample size. WebAssign generates some random values. So why? So Dr. Stevens is using that formula there because this is about how did I know to use this formula and not one of those other ones such as, the sample size equals z star squared times p hat times 1 minus p hat over the margin of error squared. Or the other version of that one for proportions is the critical value of z squared times 0.25 over the margin of error squared. How did I know we wanted to use this one here? Because so you want to be thinking about condition checks. The average number of hours of sleep of people is a quantitative variable. So we won't be using the proportion ones, right? This is about quantitative variables. We have an estimate of the population standard deviation. That's the sigma, the lowercase sigma. So that tells me we're good to go with this. So then the question comes up. People usually don't have too hard a problem with, um, plugging the numbers in. Well, sometimes they don't know what to plug in. So let's get this started. And you can see what he did, and I'll talk you through this. So we want to do a 90% confident. So you go to the normal curve table. Let's see, this is on page 280. It's either page 288 or 289 in the textbook. And I made this table available to you in Canvas if you don't have a paper copy. And if it's not I don't know if it's in the WebAssign version or not. But we're going to look at these critical values of the confidence interval. Dr. Stevens pulled this little mini table out of the normal curve table for us. We're looking for a 90% confidence level, so we're going to use a z-score of 1.645, and you see that's what he used here in the textbook. And then we need to take the population standard deviation, which is 1.25 for this version of it, and then we divide that by the margin of error. We want to be within 0.2 hours of the true mean. And then we square that. And then so you grab your calculator, you do this times this divided by 0.2, get the answer, square it, and always round up. And what is he saying? He's saying, see, that's what you would get, and you always round up. Even if that was 0.2, you would round up because rounding down to 105 wouldn't work. So that's how you do that. Now, what's different about E? Same level of confidence, a different margin of error. So what I would have to change is make this 0.1. And of course, I didn't copy that answer. It'll be a bigger margin of error. It'll be a bigger sample size because we shrunk our margin of error. And then how about for a 99% confidence interval? Well, this would even be a bigger margin of error because now we're increasing our level of confidence. I don't know if it's going to let me cancel those out. So now at a 99% level of confidence, we're going to have to go 2.575 standard deviations away from the mean. Okay, I hope this helps. I mean, really check that you're using the right formula, and then it's just pretty much a calculator question. Okay.